But I do want to start with anything 1 through 14 that you think you may not have gotten right, that you don't know how to do, that I can work out. 14? What do you want?
11.
So we'll start with 11 to 14. So this is the information you need for 11. Let's just look. Of course, we're supposed to write on a separate sheet of paper, so it's fine. So basically what I need to do here is I need this times this will equal this. Okay, so I'm going to write that down. And this just means that this is dependent on A, on the A event. So this times, well, I don't know I wrote that. I really need to write this. 920 times probability of A, which I don't know, equals 27 over 200. That's all it means. I put 2,000. That's bad. You can divide this with the calculator. I refuse to write it that way because it's so ugly. It is easier just to do this because you could do it by hand if you needed to. But calculator is easier, and so that's what you do on 11. And you get and with these calculators that do fractions, it makes it way easier. But that's okay. So just put that in there. If you can see that-ish. And then enter. I hit clear. That's not good. All right, well, I have to type it in since I erased it. But hopefully you have the answer by now. And then it looks like you're going to get the probability A is 3 over 10. And in decimal form, that would be 0.3. Or 30%. Okay, 14. 14 is just straight up probability of A times the probability of B dependent on A. So you just put it in like this. And we get 21 over 100. Okay, it's not even really algebra, but we probably need to write the answer correctly. So probability of A and B equals 21 over 100, or 21.21, which would be 21%. Okay? So basically don't make this hard. These are one-step equations. They do have fractions, but they're still just one-step equations. They just have some meaning behind them. One of our goals this year is to understand the difference between and, or, and not. And we're going to get to it again. This basic logic words. Okay. Any more on this worksheet before we start the new stuff? All right. So we'll just start the new stuff right here. 9.93. Mutually exclusive. Okay, mutually exclusive. So we're talking about events. Mutually exclusive events as opposed to dependent or independent. So independent, basically, there are two events that you want to happen, two or more events that you want to happen, but they don't really affect each other. Mutually exclusive is where you want just one of those events to happen. You don't need both of them to happen. So when we have the probability of A and B, these can be dependent or independent. And basically, we discuss things that make them dependent. Well, I didn't spell independent right. Dependent means like we pick something and we don't replace it. Independent means we always replace it. We start with the full probability, the full availability of the samples. Mutually exclusive is going to look like this. I don't know why I put it's going to be A or B. Okay? And so it's going to be worked a little different. Mutually exclusive is going to be this formula. And so we're just going to have to look at examples to make this work. So it's probability A plus probability of B. And this basically means, you can't see it, this basically means only one needs to be true. You don't have to make both of them true. Up here, both of them have to be true, and so that's why the formula is different. This one, only one has to be true, so we add the probabilities. We actually have a better chance of winning in an OR situation than an AND situation. So we're going to need to look at mutually exclusive events, and we're just going to have to read this stuff and figure out what it is. And so I will pull this stuff up so we can do this. And unfortunately, it won't show up on the video because I don't have the ability to do that right now. Okay. Let's see if I can pull this up. No, it pulled up something. Let's go here. All right. You roll a 6-sided die. The die shows an even number or a number greater than 2. So you win if it has an even number. So let's figure that even number out. And we're going to figure out if it's a mutually exclusive event or if it's not. What do we think it is, just based on my definition? Okay, I heard that. Okay, basically why it's not mutually exclusive is because of this reason. And I'm going to show you. And if it's not mutually exclusive, it's a little bit more complicated. So it shows an even number. Thank you. I didn't put the lid on. I'm a bad person. All right, this is why it's not mutually exclusive, and this is to help you understand what mutually exclusive means. So what are the possibilities? That is interesting. What is the possibilities? I wish it would stop doing that. What is the possibilities of rolling the dice the first time? What are the wins? The die shows an even number. So there's an even numbers are what? 2, 4, and what? Okay, that's the first roll. And then let's look at, hopefully this is on the screen, the second roll, or a number greater than 2. Which numbers are greater than 2? 3, 4, 5, 6. Okay. Now I'm going to go here and I'm going to show you why it's not mutually exclusive. Because the best way to explain this is not through definition, it's showing you. Okay? Here are the two events that I want to happen. I either want a 2, 4, 6, or I want a 3, 4, 5, 6. Okay? This is what makes it not mutually exclusive. Both contain those numbers, right? Okay, so we'd have to calculate probability differently than mutually exclusive. Mutually exclusive, the two sets would not have any of the same results. Okay, we're going to try another one and see what we can do. And this is the best way to understand this, because it's kind of weird, some of this stuff, but it don't make it harder than it is. All right, let's see here. Let's do the next one. Nope. Let's pretend like I didn't do that. All right, a bag of 4 marbles, 3 blue marbles, 3 yellow marbles. You randomly pick a marble. The marble's red or blue. Okay, what do we think this is? Mutually exclusive or not mutually exclusive? Okay. Can a red marble be blue? Can a blue marble be red? Then it's mutually exclusive. You won't have things that share. You're either going to get a red or a blue. And I guess we have, what, 4 reds? How many blues do we have? 3 blues? Okay. And so basically I have, to win, I either have to pull one of the 4 reds or I have to pull one of the 3 blues. And I don't have any blues over here and I don't have any reds. They don't share anything, and so I can use my formula. Okay, we're going to do one more of these and then we're going to actually work one out. Where is it at? There it is. Okay. There are 4 nickels, 3 dimes, and 5 quarters in your pocket. You randomly pick a coin. It is a nickel or a dime. What do we think? Mutually exclusive, because a nickel can't be a dime. Okay. So let's work one out. That's just boring to say that. Okay, now we're going to find the probability. Okay, a basket contains 5 apples, 5 peaches, 3 pears. You randomly select a piece of fruit. It is an apple or it is a pear. Or a peach, I'm sorry. Okay, can an apple be a peach? So it's mutually exclusive. And so you're going to have to write the probability of an apple, which there's 5 apples and how many fruit? Let's see, 5 apples, 5 peaches, 3 pears. How many total fruit in the basket? 13. Okay. And then peach. How many peaches do I have? Okay. So this is what we do in this mutually exclusive situation. I'm going to show you that. I got 5 apples and 5 peaches. Do I want it? Am I doing 2 pulls or 1 pull? I'm just pulling once. And I either want this to be true or I want this to be true. So in this case, we add it together because it increases my odds, increases my probability. So my final answer would be 10 out of 13. And then you need to check it, change it to a decimal. So what do we get? 0.77, because I rounded. So a 77% chance to win is a pretty good chance to win, right? Okay. So that's basically how this is going to work. And go ahead and look on your worksheet again. I'm going to help you with 15 just to show you how this works, because I don't want you to make it hard. So remember, our formula is PA plus PB equals PA or B. So this is how you do this one. PA plus 1/5 equals 2/5. What do I need to do to both sides to make it work? Okay, is this hard? Don't make it hard. That is just a one-step equation. We do have fractions, but we have calculators. So, all right, so let's go ahead and work on this.